A rigid gate in a river flood control structure measures 6 meters in width and 4 meters in height and has a weight of 10 kilonewtons. The longer edge of the gate is horizontal and the gate is lifted upward. Determine the force required to raise the gate when the water surface is 2 meters above the top edge of the gate. There is no water on the downstream side. The coefficient of friction between the gate and the channel guides is 0.1. Neglect both the buoyant force acting on the gate and the weight of the lifting cables. So, meron tayong 6 meters wide, 4 meters high na gate. It is longer edge horizontal. Longer edge horizontal. So, it is move up. Kung i-imagine natin, let's say, ito yung channel guides natin. So, naka-side view, ito yung gate. Merong a tensile force, hinihila sa pataas. It is moved up. So, ang pinapahanap is ano yung force needed to raise the gate. Ito daw, evaluation T. Anong force needed to raise that gate? So, it is subjected to hydrostatic force. Merong tubig dito sa upstream side, wala ng water sa downstream side of the gate. So, the coefficient of friction between the gate is 0.1. Okay, sabi sa problem is that when the surface of water is 2 meters above its up edge, ito yung ibig sabihin, above its top edge 2 meters. Alright, para mo ding klaro, draw the forces acting on the gate. Free body diagram. Mechanics, it is all about mechanics. I-draw natin lahat ng forces na nag-act dito sa ating gate. Una, merong weight ng gate. Weight ng gate is 10 kilonewtons. Pero merong hydrostatic force yung water dito na mag-act sa gate. Tawagin mo siyang FH. Okay? So remember, the characteristic of hydrostatic force is to be acting to the center of pressure. Now, kung merong force dito sa channel guide, tingnan merong channel guide dyan, magre-react. This will react and that is normal reaction. And in order po dito binigulibli yung balance siya kung saan dyan din yung ating reaction. Doon sa channel guide. Since pinipilit siyang iangat pataas and there is friction between the gate and the channel guide, so meron tayong friction dito, resistance to the force. Friction is a resistance to the force. So as you can see, in this free body diagram, ito lang yung diagram natin, you can solve for P, yung force needed to pull the gate by summation of forces vertical. Parang klaro, ang T is equals to 10 kilonewtons plus the maximum available friction yung ating gagamitin. By the way, this is the center of gravity. Now, to solve for the friction, gagamitin natin sa friction is the maximum available friction, mu times the normal reaction. Isasadad natin yung required force to raise the gate. Ang normal reaction natin is NR, which is equal to the hydrostatic force. Equal siya kasi summation of forces horizontal. They must be equal. So, therefore, we need to solve for hydrostatic force and kailangan natin yung Barth H. Location ng center of gravity from the water surface. Barth H po yan. Ilan yung Barth H? This is 4. This is 2. Kalahati. Kung 2 meters yan, that's 2 meters. Therefore, Barth H is 4 meters. By the way, this is the eccentricity. The distance of the center of gravity to the center of pressure. But in this problem, hindi naman required yung eccentricity. Alright, kunin natin si hydrostatic force. Gamma Barth H area. Gamma ng water, Barth H is 4 meters. Area, that is 6 times 4. The hydrostatic force is 941.76. And the normal reaction, again, summation of forces horizontal, is just equals to hydrostatic force. Therefore, the maximum friction available is mu times normal reaction. Mu is the coefficient of friction. And normal reaction is this one, 94.176. And to solve for the required tension force to pull the gate upward, summation of forces, vertical. We have T minus F and minus 10 kilonewtons equals to 0. And F equals to 94.176 kilonewtons. Then the tensile force required to move the gate up is 104.176, and that is letter E.